now's the time, then let's go.
Okay, so welcome everybody. I guess this is probably the last presentation you guys will be seeing at FSOSS. Hopefully everybody enjoyed it. Exactly, this year. So with me today I have Julian Egelstaff. He's the co-founder and technical architect at Freeform Solutions. And a little bit about him. He's been working in the software and IT industries for over 18 years. In 2003, he co-founded Freeform Solutions, a non-for-profit organization with a mission to help other non-for-profits use technology more effectively. Julian is also the lead programmer of Formalize, an open source project designed to provide non-programmers with the ability to create database systems on the web. Julian holds a Bachelor of Journalism and Philosophy and is a Zen certified engineer. His presentation for us today is building a CI system with free tools and duct tape. Take it away.
Thank you very much, Elizabeth. Thank you guys for being here at the end of the day. Hopefully we save the best to last. I'll leave that judgment up to you. So, free continuous integration of open source web software. The Formalize software that Elizabeth mentioned is what prompted us to look at this. Formalize is web-based data management software and reporting software. And we have a problem that is probably familiar to anyone who does software development. Who here is a developer, has developed stuff? Who here has some continuous integration system that they are working with on their code right now? Okay, so I can't make stuff up then. So the problem we have that I think everybody has is you have to make sure that the new features don't break the old features, right? What's the definition of version 2.0? You replace all the old bugs with the new bugs. So we don't want to do that. Now, Formalize has grown organically over a decade of history. So it is unfortunately true that it's not possible for us to do true unit testing on much of the code base because it wasn't ever planned out that way, et cetera, et cetera. Also, as a web-driven application, or a database-driven web application, the way the application works is heavily dependent on the runtime configuration of the application. So it's not a standard set of code that's going to work the same way all the time. Scaffolding database structures and unit tests is not fun, but I know there's ways to do that. So for us, the solution here appeared to be, and I think for a lot of web apps in the same category, the solution appears to be Selenium. I know that a lot of organizations now, including Amazon, are using Selenium testing as part of their suite of testing. Selenium is functional testing, not unit testing for web applications. What that means is, I'll show you in a moment, you record a set of behaviors in the application, and you can replay them over again and verify that they worked that way the second time. It's there's a few ways to run Selenium, but basically the state of the art now seems to be this thing called Selenium Builder, which is a free plugin for Firefox. Now this is what the Selenium Builder software looks like if you start up the Firefox plugin and you start making a test, you'll end up with something that looks sort of like this. So the basic idea to start with is that you record the actions in Firefox. If you go way back in Windows, you might remember a great little app called Windows Recorder, which was wonderful and awful at the same time. You could record things in Windows and play it back. And this is kind of the same idea, but it's all done in JavaScript interacting with the DOM inside the browser. So you record these actions, and then you can edit all the steps. There's this nice set of options. You can edit, what kind of step this is, add new ones, copy steps, and there's lots of different things you can do. It's a fairly nice interface, given all the things it has to let you do, I think. You can do variables, which is fairly handy. You set the variables, and then you can read them again. I'm not sure if you can read the little text here, but it's like $, curly bracket, test _ domain. Because up further above, we've configured localhost as the variable for the test domain and stuff like that. So, you can do, depending on how you design your tests, you can make them somewhat portable. So maybe you want to run this on multiple domains or however you want to do it. You can play it back as much as you want, of course, and you can put asserts in and stuff. It's got this wait for text present, for example, and then it moves on to the next stuff. But you can also do things like verify the text is present. And if it's not present, if that page didn't load properly, the text is not there, then the test will fail. And you'll know that something's wrong with the application. And you save it all as JSON, which is kind of nice because tests actually look like this. They're just plain text. So they're really easy to work with. It's not some weirdo format that you are forced to only work in that editing environment. Once you have a bunch of tests, you want to copy paste a bunch of things back and forth, and you can stick it in version control, and you can do whatever you want with it. So it's very nice. But it takes a while to run. A full set of Selenium tests, if you've ever worked with Selenium before, you know it can take a little while. On a complex application, you'd be looking at several hours, really, to do a full suite. We just started working on this earlier this year, and it takes about 30 to 40 minutes to run all the tests that we have at the moment. So not that bad, but it's obviously only going to get worse. This is not continuous integration. If you share, manage, and run the tests yourself. Like if I have them all on my desktop and then I send them to another developer and he runs it, that's nice. Like you can run the tests, but I mean you're testing, but it's not continuous integration. Now, FSOSS Labs. Who has heard of FSOSS Labs? Anyone? Yes. Okay. So now you can really learn something, and I can make up more stuff. FSOSS Labs is a cloud-based platform for running Selenium tests. It's one of these cloud service things out there that you pay monthly for. It offers lots of browser and OS combinations that you can test against. And it records screenshots and videos of the tests as they run. This is so awesome, so you can see where things screw up. You can see the tests running in your application. And it is free if you're testing open source. So Formula is an open source package. We're very happy to use it. And there's no limits. It's not like free for 10 tests a week or something. It's free. It just runs. It's awesome. And you can actually run your Selenium tests on FSOSS from inside the Builder plugin. So you can open up the Builder plugin and you can say, run all these tests on Selenium, please, and you put in your Selenium username and password, and off it goes. So you get the benefit of these awesome recordings and screenshots and all that, and you don't have to have your own infrastructure that you're running the tests on. But that's still not continuous integration. That's just a better platform for running your tests. So we need to fill in a bit of the gap here. And I'm going through this bit by bit because if I show you the end version at the beginning, there's too many bits. I don't think it would make a lot of sense. So I want to sort of go through it bit by bit here. What are the different pieces and what do they do? And by the end, we'll have GitHub and Travis CI connecting everything together, and it'll be awesome. It's so cool. So GitHub. Everybody know what GitHub is? Yeah. Yeah, of course you do. GitHub is awesome. We should have been using GitHub years ago. It took us a while to switch over from SVN, but anyway. GitHub is, if you didn't know, cloud-based Git repository manager with absolutely, totally amazing collaboration features. And it's free if your repos are public. Pay for GitHub if you want your repos to be private. And Travis CI. Does anybody use Travis CI? You should be up here. Travis CI is a cloud-based continuous integration platform, kind of like FSOSS, one of these things you pay for, usually monthly or whatever, different, however many tests you want to run. It spins up test servers for you in the cloud automatically in response to GitHub commits. And it is free if you are only testing public GitHub repos. So this is the baseline. This is like sort of the starting point. You got all these things. You got Selenium as like a free plugin for Firefox. You got FSOSS Labs, which is free if you're doing open source. GitHub and Travis are free if it's all public. So as an open source application, you're covered. You actually have access to a fantastic set of free infrastructure here. Question is, what the heck do you do with it? Well, first thing you need to do is on FSOSS Labs, you have a username and password, and you have to encrypt those using this Ruby thing, and there's details of that URL for how you do that. So that's just sort of step one. To be pedantic, you do have to do that step. Step two, you tell Travis to listen to GitHub for your commits. So on your Travis profile page, there's, you have something like this, and right over there on the side, you just flip it to on. So for the formalized repository, yes, please listen. And any other repositories you want, please listen. And then you set up this travis.yaml file in the root of your GitHub repo. And that basically, Travis listens for your commits, and it checks for one of these things, because this file is where all your instructions are. Now to start off with, your instructions can be pretty simple. So this is an example, really simple YAML file. This is the encrypted FSOSS Labs username and password. This is what you get out of the Ruby thing that they tell you to do. And then before you run all the tests, you have to install this test interpreter thing. And then you tell the test interpreter to go do everything according to what you've written in a configuration file. So there's like that file, and there's the configuration. The configuration file is fairly straightforward. There's more JSON. You're basically saying, yeah, we want FSOSS Labs to be running these tests. And here's a bunch of basic things like our FSOSS username and access key, which is encrypted stuff in the other file. We want to run this in Firefox, and a few other things like the job number from Travis and other things that you might want to just make available to FSOSS. Oh, and of course, very important, where are my tests? My tests are in this particular folder of my repo. I'm saying tests are in CI/selenium2 tests / asterisk. So it's going to run everything in that folder because it's the good old asterisk. There's lots more info about these at the URLs down there. So then you got all that set up. It's not a lot of code. It's pretty darn simple. You commit your tests into GitHub, so they exist in GitHub. And then Travis, because you told it to listen, says, commit in GitHub, and there's a YAML file. So Travis spins up a server for you. And at this point, because you've got the Travis server, you could be running unit tests. I focused on the Selenium tests because for our application, that's what's really important. But Travis is a full continuous integration environment. You could now be, if you had unit tests in your repo, you could have Travis go to town on them if you added more stuff to your YAML file. The first thing that Travis does up here is it clones your GitHub repo and it checks out the commit that you just made. So you have a full copy now of your canonical repository on this imaginary cloud server. So next thing it does is it's going to read all your tests and send them to FSOSS and report on the outcome. And that looks like this. You get these black screens I've been showing. Travis gives you this command line readout of what the cloud server is doing. You can actually follow it in real time. If you do a commit and then you go into Travis and you see, waiting to process these tests, you can just watch that page and it'll just show you command line by command line what the server is doing. So at a certain point in that process, you'll see, starting test 001, install formalize. Yep, did this command, yep, did this command, yep, did this command. And if you look closely at all these are just the things from the first Selenium test I showed you. Like go to this URL and click this element and wait and then click this other element and so on. So far that test is working, it's all green. Then FSOSS is, as that's happening, FSOSS is running the tests against whatever the URL is that your tests are pointing to. And it records the outcome. I will show you a FSOSS video as part of this in a minute. It's running it at the URL that your tests are at. So that's www something out there on the web. And you're not testing against the current code base in GitHub. You just copied the whole repo to Travis, but the tests are they're just testing against something on the internet. So it's still not continuous integration, but it's really close because you've got everything hooked together now. So what do we do about that? Well, it's actually fairly simple conceptually. All you need is a much more complicated YAML file. Different instructions to Travis, and it all works. So the main difference is you've got this big install section in your YAML file, and this thing on Travis is a full Linux server that's been spun up for you. So you have a full Linux server, well, install Apache and PHP on it. So here we go, install Apache and and do all this stuff, and we have to schmod some folders to make our application run and do all that kind of thing. And restart Apache at the bottom. Another thing you have to do in these more complex instructions is you have to use this thing called FSOSS Connect, which is a special tunnel, this special sort of thing that the people at Travis and FSOSS have rigged up. And it lets FSOSS reach this new server you've just made. It lets FSOSS reach out over this tunnel and actually connect to it. So instead of going out there onto the commodity internet to run your tests, you're going to run them back here. And as I say, they've made this like this little extra thing. You don't have to do much. All you do is like FSOSS connect true. It's sort of magical. They have this diagram on their website for how it works, and this is their diagram. So, and yeah, that's kind of all you need to know. You do then also need to make one other change here. Did you spot it? Go back and forth if I can. You have to use that magic rainbow port. If you don't use localhost 4445, then like it doesn't know where to go. But if you tell it that, then it'll go back over the rainbow to Travis, and it's awesome. So then everything else is the same. You push your tests into GitHub. Travis does its thing, spins up the server, starts processing all your YAML commands, and then the tests are going to start running. And now this is the part that's different. Because of the changes in our YAML file, we're not running them against some URL out there. FSOSS runs the tests against the current code base as found in GitHub because it's talking back to the LAMP server you just set up on Travis. As long as you make your test point to localhost. Like when the tests run in the browser, localhost is considered, like that's how you address the Travis server. So now you have real continuous integration because it's like the real code base that you just made a commit on and it's being tested. And this is a video of, if it runs, is this going to run? Ooh. I think, yes, I have to click a button. I click that. So yeah. So this is what FSOSS gives you. This is recorded by FSOSS as this test was running during one of our builds. And it's processing all the Selenium commands right now. Our first test is our installation routine. Because just like WordPress or a typical web application, you put all this stuff up on the server, and then you run this install script, and now you have a working application on the server. So we want to have a whole battery of tests starting with this. Because remember, the code is coming from GitHub. It's like our sort of master, unadulterated, pure code out of GitHub, what you would have if you downloaded our software and tried to install it. So we begin with the installation routine, and then the other tests just build on that and create structures and things and formulas and verify that the features are actually working as intended. And this also gives you a good idea of the speed with some caveats, because what you find if you do a fair bit of work in Selenium is, and it works. You did the installation, now we're logging in, and poof, we can log in. So like, it really works. Yeah, if you do a bunch of Selenium testing, you will come to appreciate that it is a bit runtime dependent. It takes longer. The tests run really fast. And locally, things can run, and then when it actually is running over the internet, not on the local server, then it can get tripped up. So we do put in a bunch of waits at different points to make sure that it doesn't trip over itself. But anyway, that gives you a rough idea of the pace. You can see how that would take a while once you've got a whole battery of tests. So the big payoff of this, and why I especially like this process, because there's lots of different ways you can do continuous integration, and continuous integration is very important for reasons I hope everybody appreciates, like that's why you're here, right? But what I especially like about this is developers manage the codes and tests through a unified process. We can have GitHub feature branches that contain the code changes and the tests that are applicable to that feature. That's it. That's all you have to do. You make your code, you make your test, You push it in one operation. It's one branch in GitHub. We can merge that into the master all at once. We have the code and the test together, and we don't have some other test environment that we have to make sure is seeded with the test properly, or what, is it up to the right version or any of that. It's totally unified. I think when you don't have that, it's a significant barrier to developers creating tests. And of course, you get the little build passing thing. Like, that's why we really do it, right? Because that just gives you a warm, fuzzy feeling when you see that coming up. A few other issues, though. Managing tests is hard. And this is a particular criticism people have of functional level testing. Managing tests can be hard. To make a new test, especially in the way we're doing it, like, you need to pick up where the previous test left off. Like, you need to have run our installation test and then a bunch of other tests to have created some structures. And then you can do some tests to verify those structures are working and so on. But like, it all builds one after the other. So now, 6 months later, I'm making a new feature in the software, and I'm going to make a test for that. But like, really, the most straightforward thing to do is just to make it be the next test in the sequence. But like, how do I do that? Because I've got all these other tests in front of me that have to run. You could run all the tests locally yourself to get a local version of the canonical test environment. But that's obviously going to take time. It's a bit of a pain. You got to download stuff and open up the plugin and all that, and be running your own local server. So we have a neat solution to that, I think. In Formalize, maybe you can read that at the back, I don't know, but I'll tell you what it says. In Formalize, the database, as I've said before, the database stores all the configuration information. So we've rigged up in our YAML file, we can use a special tag in our GitHub commit messages to trigger a database dump. So this is a bunch of weird looking code. Thanks very much to the OpenStreetMap project, because we just copied this right out of their GitHub stuff. And we basically said, look in commit messages for update test DB in square brackets. And if that thing in square brackets is in the commit message, then bash something, something, other shell script stuff. So we use this shell script to, we get a dump of the database, and then we push that dump back into our master branch in GitHub. So if we've done a commit that's triggered a build, and that commit has update test DB in the commit message, when the build is done, Travis will push the final state of the database back into GitHub. A little caveat on this, if you know a lot about GitHub, don't do this on pull requests. Because pull requests, when Travis builds a pull request, it merges with the master branch, and then if you push from that, really bad things are going to happen. So we, in our code, if you want to swipe our code, we actually have in the shell script some other if statements to make sure you're only doing this on a real master branch build. But the benefit of this is, with that database dump maintained at the sort of head of the test environment, then developers can quickly use that to just set up a local environment if they want that has as if all the tests had run. And we've also set it up so that if you're testing stuff in Travis, you can use the dump to basically skip all the tests and just do your one test, if that's the only one that you need to do. We do that up here. There's a bunch of comments that explain the concept, but basically if you uncomment this line, then we're going to seed the database with the testDB dump. And then when the first tests run, the system is already in that for a final state. So if you then change the configuration file to say, don't run star tests, run only my one test I'm working on, you don't have to wait however long for everything to run. So I think that makes it a little easier to work with. Yeah?
Do you test that your initial steps what it creates matches the database that you've stored? I feel like it would be another potential.
Well, our intended use case for that is just to help with the development of new tests.
Right.
And our idea is that once you've got that new test, you're satisfied with that new test and you've pushed it, then because it's all free and unlimited, we just let Travis then do another full build of everything.
Yeah.
And like, that's
Perfect.
it. Yeah. The free and unlimited thing is like in the background, but the fact that it's free and unlimited really colors your approach to how you do this stuff, because we can just sort of essentially brute force a lot of things this way, just like, oh, we'll just let it run, we'll just test it again, we'll just keep testing. It's like Frordle. So bonus. This is like actually the part I'm sort of most psyched about. It's not about testing, but here's a bonus idea. How can we unify the creation of docs with code? I mean, tests and code, sometimes it's hard to maintain that in sync. But then docs is worse, right? Like you make a bunch of changes to software and then it's like, well, we have to change the documentation, and usually in big organizations, a whole other team of technical writers to do that and all that kind of stuff. We don't have a whole team of technical writers because we're a small open source project. So, you know, our thinking was, if we could update the docs through the same feature branch in GitHub, then we could have the code and the tests and the docs all together. Wouldn't that be awesome? And the nice thing is GitHub lets you do docs. You may or may not have heard of pages.github.com. Has anybody heard of pages.github.com? You do? Pages.github.com is pretty neat. They make available, basically they give you this little web hosting space that if you want to use it to be like the homepage for your project or something, or whatever you want to use it for. In our case, we're using it for docs. Kind of like if we had a wiki or whatever. What they do is, if you set up this special branch in your repo called GH that's the first thing they do. And they'll do it automatically. If you have a GitHub repo and you just go here, you're logged into GitHub, you go there, it'll say, do you want to create a GitHub Pages branch for your project? Yes, click, done. You can pick nice, pretty themes and stuff, and it sets up all the files for you. So it makes a special branch, GH Pages. It's not in the master branch, it's like a whole separate branch, which is a bit of a pain, but we have a way around that. They use Jekyll, this site generation thing, to manage it. I mean, it could be anything. It could be raw HTML. It could be whatever you want. But they are using Jekyll. It could be whatever you want. You can make whatever site you want in plain HTML or like in anything sort of flat with no interactivity. If you want to do any real site building, you can't use like PHP or Ruby or Perl or anything. You have to use the Jekyll thing. So they generate your Jekyll site inside GH Pages. And the trick is, we found, if you like copy the entire GH Pages branch, like the whole thing, you just copy it, and then make a folder in your master branch, we call ours formalized docs, and you stick a copy of the GH Pages branch there, then what you can do is, with the right combination of magic GitHub commands, you can just periodically copy that folder to the GH Pages branch and push it to GitHub. So when you're ready to publish your docs, you basically just say, yep, our master branch folder is the way we want it, run your publish script, which looks like this, and then GH Pages gets updated, and as soon as GH Pages is updated, pages.github.com is updated automatically. So this is kind of nice. This is the magic command here. Git read tree master formalized docs. So you like check out GH Pages, and then you read just this folder out of master, and like read it into here, and then away you go, just a regular commit push, and then back to master. So it's really sweet because now we can manage code and tests and docs. And the feature branches in GitHub can contain code and tests and docs. So this is like an actual merge that happened earlier this year, last month. Four files, 4 change files. The first one is the test. So that's the JSON file for the test for this particular feature. There is an update to the formalized docs explaining a bit about how to use this feature. And we did some style sheet changes as part of that too. And then this is the actual code change. This is a fairly small feature actually, just like that's it. It's the only bit of code that went in. That's it, 4 files representing the full spectrum of everything we need for that feature, and it works. So this precisely is at that URL. We have written up docs about this whole thing in this is our GitHub Pages location. So you can sort of read all about it, and you can links to all of the code and everything if you want to try it out. And yeah, that's it. I'm happy to talk about any of it in more detail or less, or I don't know, whatever you want to talk about testing, I guess. Because that's what I got. Yeah.
Do you get a different DB dump for each branch? Or is it only on the master branch?
No, we, our thinking on the DB dump business is we have a bunch of canonical tests, right? A few dozen, I guess, or something like that. And like if you run those tests, then the application will be in this state, whatever that state.
I see.
So what we want is we want an easy way to skip running the tests and just get to that state. Because that's the state from which you need to build your next test, essentially. So we only care about that from the point of view of like, what is that canonical master branch like thing? There might be a point, I guess, for taking the dump, using the dump specifically from a branch if that branch was diverging significantly from the master. But our development model is to basically like every single feature, and usually it's not like that much code, goes into a branch, it gets reviewed, it now gets tested, and then it gets merged in.
Okay.
So we don't tend to have like sort of, you know, version 5 and version 5.1 going off like this for a while, and then putting them together. We're trying to go back to the master very regularly. So what do you think? You want to try it? Is it cool? Like, do you have who's doing web applications for which they think this might be useful or something like that might be useful? Yeah, cool. One of the interesting things for us as Formalized as open source software is the idea that this is testing the open source software. Because for our clients, we then have, you know, a few dozen at any one time sites that are in some state of development or maintenance that are using the software, and they're all very specific. Like they all have their own configurations. They are not our test application, right? So this is one of the things we've been discussing internally at Freeform is what role, if any, is there for doing something like this on a specific instance, specific client site. And the thinking so far is, well, if we are testing the majority of the features in Formalize itself, like the software itself, improving that the software itself is working, then whatever the client sites are doing, whatever features they're using are covered. Like they have been proven to work in the test. So we're not too concerned about actually testing client sites directly. But that's, you know, there's a bit of theory there, like, you know, and assumptions that, well, they're running on something at least as good as the latest version of the code, or like, you know, it's not too old, etc. Yeah, there's certainly, I think that's you know, that's somewhat true of unit testing too. In any case where there's runtime configuration issues with your software, unit tests might not catch it either. Yeah.
I'm just curious if you have an idea how much that would cost if you were for something closed source. If you're going to pay for all those services, like what's the like what are they giving you for free sort of thing? I mean, it's like $5 a month or $10 a month for GitHub.
It's at least a few bucks a month for each. Let's take a look.
$129 a month for 2 concurrent jobs on Travis CI.
Really?
Page up.
Wow.
2 concurrent jobs. I assume you can run them over and over again.
Yeah, that's true, because every time we do a commit, it does a build, right? So if like a couple developers are doing work at the same time and they both push at the same time, then we might have 2 or 3 or 4 or 5 builds actually in progress at the same time.
Have you seen the tests in Travis CI like blocked for a while? Because I know I think they have one queue for they have a queue for sort of open source stuff, and I assume that if they have paid customers coming in, they would perhaps bump.
Yeah. So far, I don't know, sometimes it takes a minute or 2 before the virtual server is built.
Mm-hmm.
But yeah, we've never sort of been sitting there like waiting.
You didn't
for it
like
to come
wait.
out.
Oh, look at you! Committed something a day later. The test.
No, it's definitely not.
That's
It's
amazing.
just a couple
fantastic.
minutes. Yeah, just a couple minutes. So yeah, like that's Wow, I did not realize that this, yeah, it's free, so I never looked, I just didn't care. I never realized that the difference is like that much. That is a significant, difference between 0 and 129 is quite a bit. Sauce, I think, is a bit cheaper.
Yeah, there's a $50 a month for 10 hours. I pulled the pricing pages up during that was.
Yeah, like if you have been around open source for a while, you've probably read various things about the magical value of the 0 price, and yeah, it like the fact that it is actually 0, so therefore we have infinite access is like, it just makes you want to do more testing.
That's got to be good.
Yeah, yeah.
Are there any other services that are similar to Travis CI?
Yeah, Jenkins is the one everybody tends to talk about, like Jenkins and Travis, and there's probably others, but those are the only two I've heard of. I don't know much about Jenkins. The sort of stereotype answer about this is like Jenkins came first, and it's older and awkward and hard to use, and Travis is cool and easy and integrates with GitHub so well. I'm not slagging on Jenkins, that's what people say. I know lots of projects do use it.
Well, you can't run Travis yourself in your
So that's a big difference. Yeah,
Jenkins, you can start up a server in your own infrastructure.
Yeah, because like Jenkins itself is fully open source, I think, right? Yeah. So you can download Jenkins and like run your own testing infrastructure if you want it. Whereas, yeah, Travis, you're on the hook unless you're open source. Yeah. Yeah.
That's cool that they got that pipe between sauce.
Yeah, the magical rainbow.
That's.
But let me tell you,
Yeah.
the docs on this, one reason I feel very strongly also about talking about this with people, because it took about 3 person days to figure out localhost 4445.
Well,
Yeah.
thank you for writing the docs.
Really, the SE interpreter, like in the YAML file, I'll go back to it. In the YAML file, like right about here. Yeah, so zoom in. Yes, it'll allow. So like this part, the SE interpreter, this is like a Node.js thing, like npm, it's installing this Node thing on the Linux server. So this is in GitHub. Like the guys who run Sauce Labs, I think the guy who is the maintainer of this, like is an employee of Sauce Labs or something like that, or has some affiliation with them. So yeah, once we figured all this out, like I did a pull request on his repo with like a 1-line doc change for, because his docs are all about like if you're using GitHub as the place you keep your tests and you're testing somewhere else. So his docs are all around the on-demand saucelabs.com. And I just added this thing like, if you're using Sauce Connect, do this. And he accepted that, and it's in the README now.
Yay.
So, yay. For those of you who ever tried to commit to open source software, I was really glad that was that easy. That's why GitHub is so awesome, because it generally makes it pretty easy to do that kind of thing. Any other thoughts, comments? End of the day, we have drinks after this, Chris?
There is.
Yeah, so people just want to get the drinks, right? Yeah. It's fine, I understand.
Beer o'clock.
Beer o'clock. Yeah. That's it? All right, well, thank you very much.
I'd like to thank Julian for coming in today and giving us our last presentation of the day. I think we all enjoyed it. It definitely sparked some tech interest in the room, I believe. So thank you very much on behalf of all of us.
Thank you very much.
You're welcome.
Thank you.